Hello guys, welcome to the continuation of the video tutorial adaptive linear neuron with stochastic gradient in Python. So last video it got cut because it was terminated it's because I ran out of disk in my one of the local disks, so that's why it just stopped abruptly. So now we'll just pick up from where I've left. So I've just imported this piece of code from my main program, this one, my the actual program that I wrote to check the functionality of this code. So I grabbed it from there and then I pasted it. So and then I was explaining you have to import pandas and matplotlib. If you don't know what this is all about, then there's another video tutorial series on this one that explains different data visualization techniques. So it's in my channel. You could just go ahead and watch that one. And after that, you have to import numpy as np. Then this line of code imports the iris dataset from the internet. So when you go ahead and print this out, so you get to see the actual data with from index till the label. Yeah, so here we go. So it takes some time. It depends on how fast your internet is and how fast your computer is. So this is the index and these are all the features and this is the label. So you have from Setosa, versicolor, which you have in between. This is the truncated data, so that's why you see these dotted lines here. And then Virginica, which is last of 3. So on each you have 50 sets of data. On Setosa you have 50, Virginica you have 50, and Versicolor you have 50. So what we're going to do is we're going to extract first 100, which will be Setosa and Versicolor, if I'm not wrong. Yeah, the from 101 to 149 it's for Virginica. So this is Versicolor. If you don't know what I'm talking about, so you just go ahead and see this one, Setosa, Versicolor, the second one, and the third one is Virginica. So, we're gonna be grabbing the rows from 0 till 100, so which will be the data corresponding to Setosa and Versicolor. So the fourth column, which is the label itself, so we're gonna grab only this one as a y value, and then we're gonna make all, if it is iris Setosa, it's gonna be -1. If not, it's gonna be 1. And then x for x from the same data frame. So we're gonna take all the rows 0 to 100 means from the starting till the 100th row. We're gonna grab from 0 till 4. That's what it is. So you could just play with this if you don't understand what it is all about. So even I play with this often to get the exact column that I want. So 0, 1, 2, 3, 4. So it won't take fourth one, it will take till 3. That's what it does. Maybe it starts from 0, 1, 2, 3, 4. Yeah, I think it starts from the index. So 0, 1, 2, 3, 4. But it won't actually take the index. So it will leave the index. But it take till the fourth column. So 1, 2, 3, 4. That's what it does. Okay. So when you print this out, so you get to see the difference between the actual data and the data that we have extracted from the actual data. So this is the actual data from the internet, and this is the data that we have extracted. So just these, but from first column, first row to 100th row. So now we extracted it. So now we're going to create an object of this class. So you can call that anything you want. You could call that anything you want. I'm going to call this ADA equals, and then you have to pass the arguments. So these are all the arguments. First, copy paste. Close this up. and we just change the iteration to make ours accurate. So I want this to be shuffled, and the random state is gonna be 1. Okay, so now I created the object of the class that it's gonna do the adaptive linear neuron machine learning algorithm. So now ADA dot, first you have to train this, so for that you have to fit x comma y. This fit method will automatically train itself, like what I explained in my last video tutorial. It's going to train and it's going to update the weight, update, weight gets updated, train again, weight gets updated. And then once it's all done, you have a weight that's capable of predicting any Setosa value that you're giving. If it is Setosa, it's going to be predicted as Setosa. If not, it's going to tell you it's not Setosa. That's what it's going to do. So now let's go ahead and print out the weight. So even though we can't make sense out of the weight because it's a result of a training, yeah, we can indeed make sense out of the weight. How? I'll just show that to you guys. So copy this, go down, paste again, change the name, print da dot fit x comma y. Then you go ahead and print w underscore, which is weight. This is actually weight. This is the weight that we define over there. And then you go here. Oh shit! New Microsoft. I don't know who that is. Print da. Oh, my friend is changing the data. Okay. So now we're going to change this iteration. So we're going to change this to 5. So now you get to see the difference in weight. If you train for more number of times, what's the weight? You could actually see the difference in weight. It will take some time. I told you before, it has to grab the data. So you could see a considerable difference between the weight. If you train for more number of times, the weight is different. So you can actually say it's different. Okay, but you could also write a prediction function, like prediction. You can call the prediction method to do the prediction. So I'll also do that one. So let's see which is more accurate. So now I fit the data. Now I generated the weight. So now what I'm supposed to do is I have to call the predict predict function, then pass a Setosa value as an argument. So I grab this one as a random, paste, close this, and then I'm gonna use the same data to do the prediction. And let's see this. If it is, this is actually, we know it's Setosa, then it should return -1, like what we set here. If not, if it returns -1, then it is right. If it doesn't return -1, it's not right. That's what it's all about, simple. Shitty syntax. I hate. Save. Wait. So both have predicted as -1, so both are accurate. So now let's go ahead and reduce the number of iteration here. Just make it 1 F5. Save on F5. Okay, now, so how am I gonna like differentiate it actually, the actual differentiation?